But the last section we're going to go through in chapter 11 is about combinations. So we've seen permutations. Now we want to go over combinations. And so a permutation, that order is important. A combination is a distinct group or set of objects without regard to their arrangement. Okay, so I'm still going to pick from a collection of things, but the order doesn't matter. So let's kind of look at some examples to really make the distinction of when am I going to be in this permutation situation versus when is this combination going to come into play. Okay. So let's determine whether the situation is a permutation or combination. Okay. And so first one, you are going to adopt two puppies from a shelter that has 10 dogs. Okay. So the order that I matter the dogs makes no difference. If I adopt this dog and this dog, it's the same as if I reverse the two. So I get the shepherd, I get the lab. Same thing as getting the lab first, then the shepherd. So here, the order doesn't matter. So this is a combination. If I consider a second example, where we're going to arrange 10 books on a shelf, if I want to count the number of ways I can do this particular situation, the order of those books does matter. If I put the history book first versus the sci-fi book first, that creates a different arrangement. So the order matters. So this is a permutation. So this is going to be the thing you have to consider about. If I'm trying to count the number of ways this is going to occur, how do I need to consider it? Is it going to matter which object I pick first versus which object I pick second? And that's going to kind of branch you out. Okay, am I going to count using my combinations techniques or do I count using my permutation techniques? And so once you figure that out, it'll make your situation a lot easier. So when you're going through the homework, you're in section 11.7. That tells you you are in the permutation section. If I'm in section 11.8, I'm definitely going to be using the combination stuff. But when I'm in a test, I have no idea what section I'm in. So I really have to be able to make this distinguished notation, order matter or not. Okay. So now let's try to figure out how can I go about counting when the order doesn't matter. And so we're going to start with an example we can actually visualize and then try to build that formula or see how the formula corresponds to it. So we're told two people are going to be selected from a club of 4. To form a committee. How many different ways can a committee be formed? So it's not like our last examples from the last section where the order I picked those people mattered, like that president, vice president, secretary. The order I selected them in placed them in a particular position. Here, if I select you for the committee, you're on the committee. Doesn't matter if you're selected first versus second. So again, the order to be selected doesn't matter. Okay. So I'm going to label my members. We're going to call them, we've got 4, A, B, C, and D. So I basically want to run through all of the possible committees. So we're going to look at the first member. And so A could be selected for the committee first, B, C, and D. All of them have that opportunity to be in the committee. Then we want to pair them up with that second member. So if A is selected, I now have 3 other possibilities. A and B could be paired together, A and C, or A and D. Now I want to go, okay, well, I've got B as that first member. What other new possible committees could I form? Well, B and C haven't been paired up, and B and D haven't been paired up. I'm not going to put A as another committee because I already have that committee with A and B. Doesn't matter if I put A here, it's the same exact committee. So in this one, we don't put A because this isn't, or A and B is not a new committee. To count. I've already taken care of that from that first situation. We've got A and B paired up here. I don't need to pair them up again here. That would double count it. Likewise, now if I go on to C being selected, I can't pair C with A or B because we already have those situations. So I only have one possibility, C and D get paired together. Now when I move on to D, it's already been paired with the 3 members. So I really get no new committees here. So in total, we have 1, 2, 3, 4, 5, 6 ways to form this committee. So in total, there are 6 possible committees. Okay. So what I'm going to do is give you the formula. Basically from 4 people, I chose 2 of them to be on this committee. And I'm choosing them in a way that the order isn't significant. So this is combinations. The number of combinations possible when R objects are selected from N objects is found by, from N, we're choosing R of them. Okay. So N factorial is still going to play a role. We have the N minus R factorial as well on the bottom, like we did with the permutations, but we also have an R factorial down here. Because when the order matters, ultimately, I have a lot more ways to go through it. I have a lot more possibilities. So we have to divide by this additional piece. Another way you might see this is from N, you choose R inside parentheses. So if you have to go into statistics, you're going to be using this quite a bit. And that is a secondary notation that tends to be a bit more common than that NCR. So ultimately, the way you kind of can think of this is from N objects, we're choosing R of them. Okay. So let's connect it with that prior example. We had 4 people to choose for our committee, and we picked 2 of them. So in the prior example, from 4 people, we picked 2. So there were 4 choose 2, which again you can write as 4 choose 2. It's 4 factorial over 4 minus 2 factorial, 2 factorial, which 4 factorial is 4 times 3 times 2 times 1. 4 minus 2 factorial is 2 factorial, 2 factorial. So that's 4 times 3 times 2 times 1 divided by 2 times 1, 2 times 1. If you go through and simplify this, the 2 times 1s cancel. 4 goes into 2, or 2 goes into 4 2 times. So you're really left with 2 times 3, which is the 6 that we were able to come up with on our own. So there were 6 ways to select the committee. So this helps us out a lot more when I have more possibilities and I can't list every single one of them. So just again, make that distinction. Does the order matter or does it not? Okay. So let's try another example. Suppose you go to an ice cream parlor. An ice cream parlor has 20 different flavors. You order a banana split and have to select 3 flavors. How many different selections are possible? So from 20 flavors, we are going to select 3 of them. So we're going to go through and calculate 20 choose 3. And again, you do have a button on most of your calculators that'll go through this, but I will go ahead and go through it by hand again. So 20 choose 3 is 20 factorial divided by 20 minus 3 factorial, and then 3 factorial. So that's 20 factorial divided by 17 factorial, 3 factorial. Okay. And again, I've got a 17 factorial down here, pretty large. I definitely don't want to write out 20 times 19 times 18 all the way down to 1. We'll use that property and pick off this 20 to get 19 factorial. Pick off the 19 to get 18 factorial. Pick off the 18 and you'll get 17 times 16 times 15 all the way down to 1, which is 17 factorial. So this way, by simplifying it like that, these 17 factorials cancel. And then 3 factorial is 3 times 2 times 1. So we're left with 20 times 19 times 18 and a 3 times 2 times 1 in the bottom. The 1 doesn't really do a whole lot of anything. So 2 goes into 20 10 times. 3 goes into 18 6 times. So this leaves us with 10 times 19 times 6, or in total, 1,140 ways to make this banana split. Okay. All right. So now let's go ahead and combine this with some of our other methods we've gone through. So we can really use this to calculate different events now. So maybe I have a couple options for one event, a couple options for a second event that I'm going to count. And in total, I want to see what happens if I combine these 2 events. So let's take a look at an example of a kid going on vacation. Matthew has 12 shirts and 6 pants in his closet. He must select 4 shirts and 3 pants to bring on vacation. In how many ways can he select this? Okay. So I've got 2 distinct events that I'm going to have happen, and then I need to go ahead and combine the 2. So let's first calculate the number of ways he can select a shirt. Okay. So from 12 shirts, we're going to choose 4 of them, and that order does not matter. So this is 12 factorial divided by 12 minus 4 factorial, 4 factorial. Or 12 factorial, 8 factorial, 4 factorial. So you can go ahead and simplify this. You can go ahead and plug it in your calculator. In total, you have 495 ways he can pick 4 shirts from his closet. And I completely butchered the spelling of shirts. Shirts. And I did it again. Wow, I cannot spell shirts today. There we go. So now I know I have 495 possibilities for this event to happen. We can do the same thing to find the number of ways to select the pants. Now in total, I have 6 pairs, and we're going to choose 3 of them to bring on vacation. So that is 6 factorial divided by 6 minus 3 factorial, 3 factorial, or 6 factorial over 3 factorial, 3 factorial. So a lot less ways to pick these pants. He has 20 possibilities to go through and select the pants he's going to bring on vacation. So now I'm combining these 2. I've got to bring shirts and pants on vacation. I've got 495 ways to select my shirts, 20 ways to select my pants. So if I'm going to do both of these, I go ahead and multiply the number for each of them. So there are 495 ways the first event occurs, and 20 ways the second event occurs. So there are 495 times 20, which is 9,900 ways he can select his clothes to bring on vacation. So a lot of possibilities. Okay? So you can probably go in your closet. You could probably figure out something similar if you want to try to pick out number of outfits. You've probably got a lot more than you realize. Let's try another example. Maybe we're going to host an event, or some of you may have had a wedding or plan on having a wedding. You often, a lot of times, have a caterer, and you have that. If you've been to a wedding, you have that cocktail hour, and you have a bunch of those hors d'oeuvres that are passed around. Just one of the weirdest spellings of the words. Never anticipated this. When you actually go to select those, you really have a large possibility a lot of times. And sometimes they're categorized into different prices. So you can't always just do the super cheap hors d'oeuvres like the cocktail weenies and that kind of stuff. You might have to select some high end. So let's try to calculate how many ways we can create a menu. So catering service is making up trays of hors d'oeuvres, which is spelled HORS d'Oeuvres. So hors d'oeuvres are those fancy little appetizers that get sent around, which are categorized as inexpensive, average, and expensive. If the client must select 3 of 8 inexpensive, 5 of 9 average, and 2 of 4 expensive, how many different choices are possible? Okay. So in this case, I've got 3 events. I need to calculate how many on each event, multiply them together. So we're going to figure out how many inexpensive options I have, how many average, and how many expensive options there are. So again, the order I select the appetizer doesn't matter. I've got 8 inexpensive ones. I'm going to select 3 of them. The order of selecting 3 makes no difference. But from 8, we're going to choose 3 for the inexpensive. For the average, from 9, we're choosing 5. And from expensive, from 4, we're choosing 2. So again, you should have a button on your calculator for each of these. I go over to mine, let's see. I don't know if this one does it. No, it doesn't look like it does. Yeah, you'll probably have to go online. If you go to Desmos.com, I know this one definitely does clear all that. It's got these 2 buttons down here, NPR and NChoosR. So let's look at the expensive. From 8, we're choosing 3. So we'll select this button. From 8, we're choosing 3. So I have 56 ways to pick my inexpensive appetizers. Okay. So breaking these down, I've got 56 ways to choose my inexpensive. I'm going to choose 9 of 5 for the average. So again, I'm on Desmos.com. So we go to the NCR. From 9, we're choosing 5 of them. So we have 126 ways we can do that. So I have 126 ways to pick my average appetizers. Then you can do the same thing for expensive. We actually did that already. From the 4 people, we selected 2 for a committee. You really only have 6 options to pick your expensive. And so we go ahead and multiply all of these together. And so we have 42,336 ways to pick that menu. So a lot of possibilities. Okay. All right. So I really just have 2 more examples. We'll do another one similar to this, but we are almost done for here. Suppose Sue is having a dinner party. She has 10 different bottles of red wine. And 8 different bottles of white wine. How many ways can she select 4 bottles of red, and 2 bottles of white. To serve. So again, I've got 2 events happening. We've got our red wine, and then we've got our white wine. For the red, she's got 10 bottles, and we're choosing 4 of them. For the white wine, from 8, we're choosing 2. So if you go ahead and calculate these, 10 choose 4, you should get 210 options for the red wine and 28 options for the white wine. So in total, there are 210 times 28, which is 5,880 ways to select the wine. Okay. So again, you can use everything you have kind of learned in combination to solve these. 210 ways this event happens, 28 ways this event happens. You multiply them when you want to combine them and have both events happen. Right. So I really have just one last question, which again is going to be some type of combination. So definitely while you're going through the review, make sure you're stopping, identifying, does the order matter, does it not? Which of these formulas am I ultimately going to end up using? So we've got one final example. At a party, there are 75 people. So definitely pre-COVID times. Everybody shakes hands. So everybody shakes everybody else's hand once. How many handshakes happen? Okay. So kind of strange, doesn't seem like it would really be fitting this combination, but think we're basically going to pair people up. I've got this one person and he's going to shake hands with 74 other people. Now moving on to the second one, he already shook hands with the first guy, so he has 73 people that he's going to shake hands with. And it kind of is going to pair people up, but again, the order doesn't matter. So we need to count how many ways we can select 2 people from the 75, where order doesn't matter. So I'm basically counting the number of ways to select 2 people because there are 2 people performing a handshake. So from 75 people, we want to see how many ways we can choose 2 of them, which again is 75 factorial over 75 minus 2 factorial, 2 factorial. And again, if you plug this into a calculator, there are 2,775 handshakes that will happen.